Okay, so real quick before we do get started, here's our agenda for the week. Today we have our team test, and your closure problems are the homework. Tomorrow we're going to do some notes on piecewise functions, do some example problems. Then you have a CUDA worksheet review. I want to point out this online review is due, so it's a little bit different. It's due Thursday by 10 a.m. before class, because this is what your test is on. So I want to make sure you actually do the review before your test on Thursday. Wednesday we'll start chapter 4 and have time to go over any questions that you'll need me to go over before your test. These resource pages here, you don't have to print them, you can, but you will need to make sure you have them open at least for our classwork, as well as you're going to want a ruler with centimeters on it. Hopefully you have access to one of those. And then Thursday during class, we're taking our chapter 3 test. I will make hopefully a post by this afternoon saying what you should expect to see on your test. But basically it's going to be similar to the review tomorrow, the team test, and the closure problems. And then you're expected to have your cameras on for both the team test and individual tests. So today when you get into your breakout rooms, you are expected to have those cameras on. Your team test is kind of like a participation grade. So that's kind of where we are with that. So I'm going to go over number 5 from the team test, because it's on piecewise functions, and after talking to all of the Math 2 teachers from last year, most of us covered this, not all of us did, but even the teachers that did cover it last year kind of did it briefly. So I want to make sure you've seen a problem like this. We're going to do this one together. We'll take notes on it tomorrow, and then you'll have a few more practice problems too. So number 5 here, it says graph the following piecewise function, f of x, and then notice it's kind of broken into 2 pieces here. Piecewise functions can be however many pieces they want. 2x plus 5 for when x is less than or equal to, or sorry, less than -2, and x squared minus 4 if x is greater than or equal to -2. So what you're going to want to do on a problem like this is similar to how I made that system of inequalities last week. You're going to want to make a table for each of these. So this first one is 2/3 x plus 5. This first piece is when x is less than -2. So your table has to be numbers that are less than -2. So it has to stop at -2. And numbers that are less than -2 would be negative numbers. Our other table, and even though it doesn't say or equal to -2, we still include -2 in the table. So whatever this like endpoint is, that's where your table either starts or stops. Our other table for x squared minus 4 is going to start at -2, and then it wants numbers greater than or equal to -2. So -1, 0, 1, 2, 3, so on. So to set up your piecewise functions, you make a table for each piece, and then you start or stop at whatever this endpoint is. And then just like we were doing last week, we're going to want to just kind of plug these in. So 2/3 times -7 plus 5. So 0.333 or 1/3. Remember to make this a fraction. On my calculator, I do math and then hit enter, and it'll turn it into a fraction. So 2/3 times -6 plus 5, I get 1. And then I could keep filling this table in. I'm just going to copy this equation and change this number. So this is 5/3. 7/3. And we can tell by the pattern that it's going up by 2/3, which we should know because this is a linear equation. The y-intercept is 5. The growth is 2/3. So this is 11/3, which is the same as 3 and 2/3. So this point here is going to be an open circle because it doesn't have the or equal to. So we're going to plot all of these points, and we could have kept going with more negative numbers. So at -2, we're at 3 and 2/3, and it's an open circle there. At -3, we're at 3. I'm only going to plot the other whole number at -6. We're at 1 because it's linear. So that part of our function looks like that. And then same thing for this other piece of our function. We plug it in. -2 squared we know is 4 minus 4 is 0. -1 squared is 1 minus 4 is -3. 0 minus 4 is -4. 1 squared is 1 minus 4 is -3. 2 squared is 4 minus 4 is 0 again. 3 squared is 9 minus 4 is 5. And since this point right here at -2 was kind of that boundary, since it has the closed circle, or sorry, since it has the or equal to, it's going to be our closed circle. So when you plot the point -2, 0, it's a closed circle. And so that's what this piecewise function looks like. I want to point out a couple of things. You do not connect these points here. So this is an open circle because that means as we get really, really close to -2, it could be -2.01, -2.001, etc. As it gets really close, we're getting there, but we can't quite have it be -2 because it wouldn't be a function. Remember, to be a function, every x value can only have one y value. So if x is -2, we're down here. If these points happen to overlap, it would just be a point there. That's not the case here, obviously. So on a piecewise function, and we'll do more of this tomorrow, just kind of, you make your tables, you fill them in, and then you decide if those boundary points should be open or closed. So with that,